Hello everyone, today we are going to start the third part of factorials in which we are going to discuss few questions. So let's start with the first question. The question is find number of zeros at the end of 3 into 6 into 9 into 12 into so on till 201. Okay, so let's take k is equal to 3 into 6 into 9 into 12 into so on till 201. Now we can write 3 as 3 into 1, 6 as 3 into 2, 9 as 3 into 3, 12 as 3 into 4 and 201 as 3 into 67. So overall we can see that total there are 67 brackets are there. In every bracket the first number is 3. Okay, so first number is 3, so let's multiply every first 3 of each bracket. Okay, so that will become how much? 3 to the power 67. Okay, that will become 3 to the power 67. And which terms are remaining now? 1 into 2 into 3 into 4 into till 67. Okay, these terms are remaining, so multiplication of these terms is nothing but 67 factorial. So now effectively we want to find the number of zeros at the end of k, means we want to find the number of zeros at the end of 3 to the power 67 into 67 factorial. To find number of zeros we want to find IGP of 10 in it. So to find IGP of 10 we need to find IGP of 2 and IGP of 5. Okay everyone, so first of all let's find IGP of 2 in 3 to the power 67. Okay, 3 to the power 67 is not having any multiple of 2 in it. Okay, so that is why IGP of 2 in that term is 0. Similarly IGP of 5 in 3 to the power 67 is also 0. Okay, because 3 to the power 67 does not include any 5. Now let's find IGP of 5 in 67 factorial. Okay, if we divide 67 by 5 the quotient is 13, and if we divide 13 by 5 the quotient is 2. So sum of all these quotients is going to be 15. So IGP of 5 in 67 factorial is 15. So over here we can say that for sure IGP of 2 in 67 factorial is going to be more than 15 only. Okay, so overall IGP of 2 becomes how much? Something more than 15, and overall IGP of 5 becomes 0 plus 15, that is equal to 15. Okay, so overall there are 15 5s and there are more than 15 2s. So how many complete pairs of 2, 5 we can form? Total 15 complete pairs of 2, 5 we can form, so that we can see that the value of k ends with how many number of zeros? The value of k ends with total 15 number of zeros. Now let's do one more question of the same type. Okay, the question is find number of zeros at the end of 5 into 10 into 15 into 20 into so on till 335. So let's take k as 5 into 10 into 15 into 20 into so on till 335. So over here we can express 5 as 5 into 1, 10 as 5 into 2, 15 as 5 into 3, 20 as 5 into 4 and so on, as 335 as 5 into 67. Okay, so over here we can see that total how many brackets are there? Total 67 brackets are there. Okay, in every bracket the first number is 5, so let's multiply the first number of every bracket. Okay, so total 67 brackets are there, so multiplication of these 67 5s is going to be how much? 5 to the power 67. Okay everyone, so the value of k is nothing but 5 to the power 67 into the remaining terms are 1 into 2 into 3 into 4 into till 67. The remaining terms represent 67 factorial. So the k is equivalent to 5 to the power 67 into 67 factorial. Okay everyone, so now we want to find number of zeros at the end of the given expression, means we want to find the IGP of 10. To find IGP of 10 we want to find IGP of 2 and then IGP of 5. Okay everyone, so first of all let's find IGP of 5. Okay, in 5 to the power 67 we can see that IGP of 5 is how much? 67, because it is 5 to the power 67, there are 67 number of 5s are there. So in 5 to the power 67 the IGP of 5 is going to be how much? 67. And in 67 factorial the IGP of 5 is going to be how much? 13 plus 2, that is equal to 15. So overall IGP of 5 is going to be how much? Overall IGP of 5 is going to be 67 plus 15, that is equal to 82. So now let's find IGP of 2. In 5 to the power 67 we can see that IGP of 2 is equal to how much? 0. And now let's find IGP of 2 in 67 factorial. It is going to be how much? Let's have a look at it. If we divide 67 by if we divide 67 by 2, the quotient is 33. Divide 33 by 2, quotient is 16. Divide 16 by 2, quotient is 8. Divide 8 by 2, quotient is 4. Divide 4 by 2, quotient is 2. Divide 2 by 2, quotient is 1. So let's add all these numbers. The addition of all these numbers is going to be how much? 64. So the overall IGP of 2 is going to be how much? 0 plus 64. That is equal to how much? 64. So over here in K, total how many 2's are there? Total 64 2's are there. Total how many 5's are there? Total 82 5's are there. So how many complete pairs of 2, 5 we can form? Total 64 complete pairs of 2, 5 we can form. That is why the value of K ends with how many number of zeros? The value of K ends with 64 number of zeros. Okay, the next question is find number of zeros at the end of 37 factorial into 54 factorial. Okay, so first of all, let's find individual number of zeros at the end of 37 factorial and 54 factorial. For that, let's find IGP of 5. In 37 factorial, the IGP of 5 is going to be how much? Divide 37 by 5, the quotient is 7, and divide 7 by 5, the quotient is 1. So the sum of the quotients is how much? 7 plus 1, that is equal to 8. So 37 factorial ends with how many number of zeros? 8 number of zeros. Now let's talk about 54 factorial. Let's find IGP of 5. Divide 54 by 5, the quotient is 10. Now divide 10 by 5, the quotient is 2. Divide 2 by 5, the quotient is 0. So we need to stop here. So in 54 factorial, the IGP of 5 is going to be how much? 12. So the number of zeros at the end of 54 factorial is going to be 12. So over here from this we can say that 37 factorial is nothing but 10 to the power 8 into A, and 54 factorial is nothing but 10 to the power 12 into B. So now we want to find 37 factorial into 54 factorial. Okay, so we can write 37 factorial into 54 factorial as 10 to the power 8 into 10 to the power 12 into A into B. That is nothing but 10 to the power 20 into A into B. Okay, so from this we can say that A and B are the numbers whose unit digit is not going to be 0. Okay, the unit digits of A and B will not be 0. The unit digits of A and B are going to be even number. They can be 2 or 4 or 6 or 8. So from this we can say that A into B cannot end with 0. Okay, the multiplication of A and B is not going to end with 0. So the number of zeros at the end of 54 factorial into 37 factorial, okay, is equal to 20. Okay everyone, so now let's start with another question. Find number of zeros at the end of 54 factorial divided by 37 factorial. Okay, so first of all, let's find the individual number of zeros. So as per our last calculation, the 37 factorial will end with how many zeros? 8 zeros. And 54 factorial is going to end with total 12 number of zeros. So 37 factorial is nothing but 37 factorial is nothing but 10 to the power 8 into A, and 54 factorial is nothing but 10 to the power 12 into B. Now we are supposed to find the value of 54 factorial divided by 37 factorial. Okay everyone, so 54 factorial divided by 37 factorial is nothing but 10 to the power 10 to the power 12 into B divided by 10 to the power 8 into A. That is nothing but 10 to the power 4 into B divided by. Okay everyone, similarly look at, as per the previous question, okay, the unit digits of A and B are not going to be 0. Okay, the unit digits of A and B are going to be a even, that is 2 or 4 or 6 or 8. So B divided by, okay, B divided by A is never going to end with 0, and the value of B divided by A is going to be integer only. So from this we can say that 54 factorial divided by 37 factorial is going to end with how many number of zeros? Is going to end with total 4 number of zeros. Okay everyone, after this let's have a look at next question. The next question is, we are supposed to find the number of zeros at the end of 54 factorial plus 37 factorial. Okay, so let's take K is equal to 54 factorial plus 37 factorial. Now the 54 factorial is nothing but 54 into 53 into 52 into 51 into 50 into so on till 38 into 37 factorial. Okay everyone, and plus 37 factorial as it is. Now we are going to take, now look here, now can I say the multiplication of 54 into 53 into 52 into 51 into 50 and so on till 38. The unit digit of this multiplication is going to be how much? The unit digit of this multiplication is going to be 0. Okay, the unit digit of this multiplication is going to be 0 into 37 factorial as it is, bracket close, plus 37 factorial. Okay everyone, now let's take 37 factorial common. Now let's take 37 factorial common. What is remaining in the bracket? Okay, in the bracket there is a number which ends with 0 and plus 1 is remaining. So the value of k is going to be how much? 37 factorial into the number which is going to end with 1. Okay everyone, so the number of zeros at the end of 54 factorial plus 37 factorial, it's same as the number of zeros at the end of 37 factorial. So we want to find the IGP of 5 in 37 factorial. That is going to be how much? Divide 37 by 5, the quotient is 7, and divide 7 by 5, the quotient is 1. So the sum of quotients is 7 plus 1, that is equal to 8. So the number of zeros at the end of 54 factorial plus 37 factorial is going to be 8. After this, let's have a look at the next question. The next question is, we are supposed to find the number of zeros at the end of 54 factorial minus 37 factorial. Now 54 factorial minus 37 factorial, okay, in this 54 factorial we can write it as 54 into 53 into 52 into 51 into 50 into so on till 38 into 37 factorial and minus 37 factorial as it is. Now look here, so in this bracket the 54 into 53 into 52 into 51 into 50 into so on till 38, okay, this multiplication is going to end with 0. So the value of k becomes how much? 0 into 37 factorial, sorry, the number which ends with 0, okay, the number ending with 0 into 37 factorial minus 37 factorial. Okay everyone, now let's take 37 factorial common. If we take 37 factorial common, what is remaining in the bracket? In the bracket there is a number ending with 0 and then minus 1. Okay everyone, the number ending with 0 minus 1, the unit digit of this subtraction is going to be how much? The unit digit of this subtraction is going to be 9. Okay, so the value of k is going to be how much? 37 factorial into a number which ends with 9. So from this we can say that the number of zeros at the end of 54 factorial minus 37 factorial, it's same as the number of zeros which is at the end of 37 factorial. Okay, so for that we need to find IGP of 5 in 37 factorial. That is nothing but 7 plus 1, that is equal to 8. So the number of zeros at the end of 54 factorial minus 37 factorial is equal to 8. Okay, so now let's do the next question. The next question is, we are supposed to find the number of zeros at the end of 76 factorial minus 75 factorial. Okay, we are supposed to use the same method which we used in previous one. Let's have a look at it. So the value of k is equal to how much here? 76 factorial minus 75 factorial. Okay, now 76 factorial we can write it as 76 into 75 factorial minus 75 factorial as it is. After that, let's take 75 factorial common. If we take 75 factorial common, what is remaining in the bracket? 76 minus 1. So the value of k becomes how much? 75 into 75 factorial. Okay everyone, the value of k becomes 75 factorial into 75. Okay, now after that, let's find, we want to find the number of zeros. Okay, we want to find the number of zeros, so we want to find IGP of 10. Okay, to find IGP of 10, what we need? We need IGP of 2 and IGP of 5. Okay everyone, so k is nothing but 75 into 75 factorial. Okay, 75 we can write it as 5 square into 3 into 75 factorial. Okay, so now let's find IGP of 5 first of all. Over here the IGP of 5 is going to be how much? 2. In the first bracket IGP of 5 is going to be 2, means power of 5 is 2 there. Okay, now in the second bracket IGP of 5 is going to be how much? Divide 75 by 5, the quotient is 15. Divide 15 by 5, the quotient is 3. So IGP of 5 is going to be how much? 18. Okay everyone, so overall IGP of 5 is going to be how much? 2 plus 18, that is equal to how much? 20. Overall IGP of 5 is going to be 20. Now let's find IGP of 2. IGP of 2 in first bracket is 0, and IGP of 2 in 75 factorial is obviously going to be more than 20. Okay, so IGP of 2 in 75 factorial is more than 20, that we do not need to calculate. So from this what we can say is the total number of pairs of 2, 5. Total how many pairs of 2, 5 we can form? Total 20 pairs of 2, 5 we can form. So the number of zeros at the end of 76 factorial minus 75 factorial is going to be how much? 20. So 20 is the answer. Okay everyone, now let's do one more question. Find smallest number by which 53 factorial is to be divided to get result as odd number. Okay, find smallest number by which 53 factorial to be divided to get the result as an odd number. Okay, so if we want to convert 53 factorial into odd number, then we need to cancel all 2's in it. Okay everyone, so for that we need to find how many 2's are there in 53 factorial. That is nothing but IGP of 2 in 53 factorial. So let's find IGP of 2 in 53 factorial. Okay, divide 53 by 2, the quotient is how much? 26. Divide 26 by 2, quotient is 13. Divide 13 by 2, quotient is 6. Divide 6 by 2, quotient is 3. Divide 3 by 2, quotient is 1. Divide 1 by 2, quotient is 0. So we need to stop here and add all these quotients. This addition is going to be how much? This addition is going to be 49. So IGP of 2 in 53 factorial is 49, means in 53 factorial there are 49 number of 2's are there. So if we want to cancel out all the 2's in 53 factorial, we need to divide 53 factorial by 2 to the power 49. Then we can cancel out all the 2's which are available in 53 factorial. Okay, and now the next question is find IGP of 2 in 32 factorial plus 33 factorial plus 34 factorial plus so on till 70 factorial. Okay everyone, so let's do this. Let's take k is equal to 32 factorial plus 33 factorial plus 34 factorial plus so on till 70 factorial. Okay, now this 32 factorial we'll keep it as it is. Okay, now this 33 factorial we can write 33 factorial as 33 into 32 factorial. Okay everyone, 34 factorial we can write it as 34 into 33 into 32 factorial. After that 35 factorial we can write it as 35 into 34 into 33 into 32 factorial. Okay everyone, after that 36 factorial we can write it as 36 into so on plus so on till 70 factorial. Okay, so after that what we are going to do is we are going to take 32 factorial common. Okay everyone, if I take 32 factorial common from the first term, 1 is remaining. Okay, if I take 32 factorial common from second term, 33 is remaining. If I take 32 factorial common from third term, what is remaining? 34 into 33 is remaining. Okay everyone, if I take 32 factorial common from fourth bracket, what is remaining? 35 into 34 into 33 is remaining. Okay, and plus so on till 70 factorial. Okay everyone, now after this look here, after this 1 plus 33 is nothing but 34. Okay, 1 plus 33 is nothing but 34 and the remaining terms as it is. Okay everyone, now what we are going to do is in this bracket we are going to take 34 common. Now look here, if I take 34 common from this, 1 is remaining. If I take 34 common from this, 33 is remaining. If I take 34 common from this, 35 into 33 is remaining. Okay, bracket close. Now plus 36 into 35 into 34 into 33 plus so on. Okay everyone, so now over here this bracket we can write it as what? Tell me, 34 into odd number. Okay, 1 plus 33 plus 35 into 33 is what? Odd plus odd plus odd, that is equal to what? Odd. So this is nothing but 34 into odd plus next bracket is 36 into something plus so on. Okay everyone, so now 36 into odd number is going to be a number which is multiple of 2 but not 4. Okay, 34 into odd number, this number is a multiple of 2 because 34 is a multiple of 2, but 34 is not a multiple of 2 and odd number is not going to be a multiple of 2. So from this we can see that 34 into odd number is a number which is multiple of 2 but not 4. But this 36 into 35 into 34 into 33, this number is what? Tell me, this number is multiple of 4 because 36 is a multiple of 4. Okay, and after that every bracket is going to be multiple of 4 because in every bracket after that 36 is going to be there by default. Okay everyone, so from this what we come to know that first number is non-multiple of 4 and the remaining all numbers are multiple of 4. Okay, so non-multiple of 4 plus multiple of 4, this addition is always going to be non-multiple of 4. Okay everyone, so finally the value of k we can write it as 32 factorial into a number which is multiple of 2 but not 4. Okay, so the IGP of 2 in 32 factorial is going to be how much? 16 plus 8 plus 4 plus 2 plus 1. Okay, now we all know how to find IGP of 2 in 32 factorial. That is going to be how much? 31. Now IGP of 2 in this bracket is going to be how much? This bracket is multiple of 2. Okay, and this bracket is not a multiple of 4. So in a prime factorization of this bracket, the power of 2 is going to be 1. It is not going to be more than 1 because this bracket is multiple of 2 but not 4. So in prime factorization of this bracket, the power of 2 is going to be 1 only. Okay, so IGP of 2 in this bracket is going to be 1 only. So final IGP of 2 is going to be how much? 31 plus 1, that is equal to 32.